Hello everyone, and welcome to the final week of lecture in Unit 1 of the Introduction to Data Science module. This week we'll be releasing a video, a conclusion video, just like there was an introductory video. That conclusion video will cover downloading the course content and continuing your studies beyond this course. But the main topic we'll be covering this week is what's called Object Relation Mapping, or ORM. So we'll be in this Classes and ORM notebook. And we had a lecture many weeks ago about classes and object-oriented programming. And then we've also recently had, last week, lectures about SQL databases. And today we're going to bring these ideas together because often we might write some program in Python that uses a database on the back end for storing and retrieving data. And it's not going to be very convenient to try to run SQL queries from our program, because SQL queries are written in SQL, whereas our program is written in Python. And not only are these two different languages, but they take very different perspectives on how the languages should work. So Python is more object-oriented, whereas SQL is what's called a declarative language, where we don't typically define functions or variables even, but we simply state, give me this, give me that, do this, do that. And the whole operation is essentially like transactions with a machine. So we're going to work through an example of building a class, once again, to represent some employees at a company. So perhaps we are a human resources manager and we are working with employee data, their educational background, their salary, which project they're assigned to, who their boss is, who else is on their team, all these sorts of things. So we're going to write a class to do that. And then we're going to move on to actually working with this example in a database through Python. So let's get started by defining a sort of base class that we're going to use for as a sort of, we're going to inherit from this base class for a number of subclasses that will expand upon its functionality. So we're first, if we're building up a company is comprised of people. So the first thing we're going to do is define this person class. And a person has, as far as the things we care about, a name, an age, a degree, and a salary. And this person object is not going to be capable of very many operations. Basically, it's just going to have these attributes, and it's going to be able to describe itself by printing out or returning a string with these attributes formatted in a particular way. So that's very simple. We can make some people. My name is Dylan. I'm 29 years old. I'm actually 28 years old. I know how old I am. I have a PhD in physics. And my salary is $95,000 a year. And I can create that person object, and that person object can describe itself. So this works just like we would expect any object to work. Now we're going to describe what's called a mix-in. A mix-in is a class that we don't intend to be necessarily a standalone object ever. We don't expect to ever instantiate objects of that class, but that class defines certain methods that might be useful across a broad range of classes. So we might want to mix this class into some other classes. And this is a new idea we haven't dealt with before in class definitions or in discussing object-oriented programming, but it's a fairly common practice for this kind of use case where when I created a person object, I could put any kind of degree that I wanted. But then we might get things like PhD, as well as doctorate or doctorate of philosophy. And so if we want to control what gets input there a little bit, we might want to enforce what's called data validation. So we will validate the data by restricting what kind of values can be passed in for particular attributes in our object. So the way we can do that is defining this mix-in, this validate mix-in. And all this validate mix-in is going to do is introduce this validate method, which accepts some element as well as a list of allowed values. So this element is just like a value that we might assign to some particular attribute, and this is the allowed values. And if the element is not allowed, then we'll raise an error. Simple enough. I use this kind of validation for many things. For instance, when writing the application that you filled out to apply to this course, you had to answer some questions such as, what is your age? And we have validation on that form so that you can only submit numbers for ages. You can't submit words. And then we can make this degree class, which will inherit from the validate mixin. I'm calling this a mixin, but it's just another class. Mixin is a conceptual distinction, not a syntactical distinction. So this degree is going to inherit from this validate mixin, and we define some allowed levels of degree. So when we create a degree object, it has a level and an area. And we validate the level that's specified at the instantiation of a new degree object against the allowed levels. Then we go ahead and just set those attributes. So if, for example, I try to create a degree object with PhD physics, that works fine. However, if I did doctorate, that's not in these allowed levels. So when we go to validate this level against allowed levels, I'm going to end up raising this value error. Doctorate is not allowed for class degree. So we were able to use this validate method because we inherited it from the validate class up here. This is really useful when constructing data sets from user input data. If you're doing any kind of like manual entry, you're going to want to have some form of data validation to ensure that to ensure like certain standards are enforced across the data set, so that we have uniform values that we know, and we don't have to clean it up later to make sure that, like, for instance, doctorate becomes PhD. Likewise, we can enforce validation on salary. So we're also going to define some salary objects with some allowed pay periods. So when we initialize a salary object, we validate the pay period against the allowed pay periods. So this is very similar to what we did for degree, but now applied to salaries. And again, if I make a salary and I say every week I'm paid, I don't know, $900, something like that. 900 not allowed. Oh, I got this backwards, sorry. The number goes first. There we go. So this would say I was making $46,800 a year. This gets calculated in the Repper method. Bi-weekly, I make half that amount. But if I were to say daily, I would raise that validation error. Daily is not allowed for class salary. And this is, again, very useful for any time we have manually entered data. Maybe I misspell weekly and I just put weekly, and I won't be allowed. I'll raise an error and say, hey, you messed up. Double check that you spelled everything correctly and are putting in a valid value. That's the purpose of this error message, to alert me that I've done something wrong and I need to double check what data I've entered. So now we'll make our first proper person, which is subject to data validation, and also where the degree and salary are formalized in degree and salary objects. So we made a person object whose name is Eric. He's 25 years old. He has a master's in physics, and his salary is $5,200 a year. I'm going to pause. I'm going to break the video here and go to the next video. I think we've already learned a lot just in this video, even about classes, a topic we already know quite a bit about. We learned about mix-ins, which can be used to define methods we would like to introduce to a broad range of objects or classes, dissimilar classes. Degree and salary have little to do with each other in terms of our Python code, but they're both going to inherit from this validate mixin, which will introduce the ability to perform data validation. We also learned what data validation is and why it's important. In the next video, we'll carry on with our example, building up more classes which build upon this person class to create more specialized people in our company, namely employees and managers.